In the next few videos, we're going to dive deeper into object-oriented programming, and there are 4 relevant PowerPoint slides for this: Objects 1, Objects 2, and then ultimately we're going to get into inheritance. So there's inheritance 1 and inheritance 2 as well. Obviously, we're going to start at the beginning here, so we're going to start with Objects 1, so we'll go to that PowerPoint. I'd also like to point out that if you go to the code examples, you'll see an Objects 1 zip file that contains a package. I'm just going to go ahead and put that package into our Liang samples project so we can work with that, and then ultimately we're also going to get into some other examples of my own that are under inheritance, and then also kind of ties in hand with inheritance, this notion of polymorphism, so that's to come. But for now, I'm going to go ahead and download the Objects 1 and put it into the Liang source folder, and that's what I will use. I might also add that if we go to the Liang's project, you'll see some examples from chapter 9 and 10 and 11, and those are the principal chapters that we're going to be covering in the coming video lectures. So you can see here with the Chapter 9 package and its associated classes, I'm going to not work directly with these ones. I'm going to work with some that are very, very similar, that are from an earlier version of the textbook. I kind of like the sequencing that took place in that earlier version of the textbook. So the examples are very, very similar to what we got in Chapter 9. Not exactly the same, though. So as you can see in my Liang 11e samples folder, under the source subfolder, this is the project folder, these are the source files, here's all the packages, and I just put this new folder called objects, and it has these classes, and we are going to start with SimpleCircle stuff, and then we're going to expand and look at some things with a little more nuance afterwards. And here in Netbeans we see this package that I've just put there, and this TestCircle is what we're going to start with. So let's get started with the first PowerPoint to go through here. I'm calling it Classes and Objects. This corresponds principally with Chapter 9 material. And just to remind you, this is something we talked about very early in the semester when I was kind of giving an overview of the course. Here's our principles of object orientation, the notion of encapsulation, where the data and the behavior of an object are kind of bundled together into a single unit. This was very different from the old days of programming where you had data in one place and you had all kinds of tasks and procedures and whatnot in another. For example, in a COBOL environment, you would have a program basically of source code, and you had this thing called the data division and the working storage section that had your data, and then somewhere completely separate, you had something called the procedure division that had all your code. And unless you did some very good documentation and was kind of explaining where to look for things in your procedures, you really didn't have them bundled together into these nice little modular units that did behavior. Now, when object-oriented programming came about, that changed. And that was a revolution in coding, and it really probably was taking place in the 1980s and 90s is when we really started to see it, explode. And so this notion of encapsulation is an important aspect of things. It kind of ties in with ideas of modularity that we talked about before when we talked about tasks and subtasks and things of that nature. But now it's not so much just you got tasks and subtasks, but you actually have fully behaving pieces of data. And the string is an example of that. So you have encapsulation of the data of the string and the behaviors of the string all encapsulated in a single class. So that's what the notion of encapsulation is about. Now, the next thing, information hiding, so a lot of people will call that part of encapsulation as well. So you might also think of encapsulation as this notion of providing some public interface to the user and hiding the details of the implementation via private members. So we're going to be able to discuss the use of visibility modifiers, private and public, and something else called protected with respect to information hiding. So like I said, some folks are going to call it the same thing as encapsulation, or it's kind of part of what encapsulation is about. I like to separate those concepts myself. But you'll often see these notions of providing the interface to the user via public members and hiding details via private members tied in with encapsulation or associated with the concept of encapsulation. Now, this information hiding might remind you of something we talked about towards the end of our discussion of methods, the notion of abstraction, where really all the user needs to know, the user of a class. So I am a user of a class. I didn't create the string class, for example. I'm a user of the string class. All I really need to know about is how I use it. And so information hiding kind of ties in with that. So it's really serving a couple of purposes. One purpose is it's hiding these implementation details so we don't have to worry about that. Another purpose is it's protecting data from perhaps bad inputs or things of that nature, and making sure that when we try to put data into the variables of a class, the member variables, the attributes of a class, that there's some kind of check taking place that is ensuring that it's going to be, decent quality data. So the notion of encapsulation and information hiding, we're going to definitely be focusing on that in these first couple of lectures. And then later on, we're going to get into inheritance, this notion of hierarchies, categories, and subcategories. You would have had something similar to that in the database class in 330, where we talk about supertypes and subtypes, so classes and subclasses, and the notion of inheritance, inheriting the attributes from above or inheriting the behaviors from above. Is something that you'll see. And then this notion of polymorphism, the idea that we might have an exactly identical signature, an exactly identical method header of a superclass and a subclass, and depending on specifically what is this instance an instance of, it could invoke different behaviors. This is often called overriding, method overriding, which is not to be confused with overloading. Overloading had to do with the same method name but different parameters. No, we're talking about exactly identical signatures in a superclass and a subclass, and that brings us to polymorphism. So this notion of inheritance and polymorphism, we're not going to get to it right away, but we are certainly going to see as we progress forward through this set of slides here, the notion of encapsulation and information hiding. So I think we need to get a little bit detail about what our terminology is. Classes versus instances. A class is a category, an instance is an object. Again, to relate it to database talk that you would have had in 330, a class would be roughly the same as an entity type. With in the sense that it has fields, it has variables, sometimes they call them fields. However, it's different from an entity type in our ER modeling terminology because in addition, it has behaviors. So there's data and behaviors all embedded in a class, a category of things. And then an instance is kind of like an entity instance in our ER modeling terminology from before. That's an actual piece of data, and it's created on the heap. And it also, as I said, it's not just data that's on the heap, but it's also in the sense that it has these attributes, these member variables. And sometimes you'll see the word fields being used for that as well. So in addition to having the variables, but it also has behaviors. String does behaviors. Remember, it does give you a substring. It converts to uppercase if you want. So there's all kinds of behaviors that a string object can do. So classes and instances. So let's start looking at our first example here. We actually have a source code file that has two separate classes, one called TestCircle and another called SimpleCircle. So TestCircle is an application class. Well, how do we know it's an application class? Because it has a main method, right? And SimpleCircle is another kind of a class, and this is a class that is intended to be instantiated. In other words, this is a class where we're going to make objects of it. One kind of clue that you can come up with when you're looking at the source code of a class about whether it's something that you expect to be instantiated or not is if you got a lot of statics in here, or nothing but statics, as we have here, that's not supposed to be instantiated. We're not going to say test simple circle x equals new test simple circle. No, we're not going to be doing something like that. We could, but it's not really what the point of that is. But on the other hand, we will be creating instances of these simple circles. And each one of these instances is going to have its own radius. This is a member variable declaration. This is different from the variables that we've declared up till now because everything has been something local in the main method or in another method. And it also has something called a constructor, which is a method. And notice that the method's name is exactly the same as the name of the class. Usually when we think about methods, in our camel case notation, we begin with a lowercase, but that's not going to be happening with a constructor because a constructor has exactly the same name as the class. So this is what's called the default constructor. And lo and behold, we're doing a little bit of overloading here. That's often the case. So a default constructor, if I want to create an object and I'm not specifying what the radius is, it's just going to assume the radius is 1. An overloaded constructor, it has a different argument. That's what makes it overloaded. Remember our discussion about overloaded. Has a different argument than the other one. Same name, different argument. Basically, we're passing the value that we want the radius to be. And then finally, we have a declaration of a method that will be done on a specific instance, on the specific instance of the circle class. Notice that none of these have the word static in front of them. And notice also that the constructor doesn't even have a return type. Constructors are unique in terms of methods in that they do not have any kind of return type, even void. There's nothing in front of the name of the class here in our constructors. So this notion that all of our data and all of our behaviors are wrapped up into this little bundle that we call SimpleCircle is an example of what I'm calling encapsulation. Now that we're talking about object orientation, we should start to become familiar with the diagramming methodologies used for object orientation. Similar to ER modeling with database stuff, we have something called UML, Unified Modeling Language, and so there's the notion of a class diagram, which is representing the classes in the system. Kind of similar to an entity diagram, in the sense that you got boxes representing the entities or boxes representing the classes. But this is divided into 3 parts. It has the name, it has whatever the attributes are, and then it also has the behaviors, the operations, methods, and that includes the constructors. So an example UML class diagram, this was drawn in Visio, is for this particular one. Here's the name, here's the attributes, and here is the operations. And as with ER modeling, remember with ER modeling, you could be as explicit and detailed or as abstract as you like. Sometimes we're just sketching things. Sometimes we really want to go into detail here. So here's our notation. If we want to get into detail in specifying data types, for example, we can include those, and this is the notation for doing that. Here's our constructors. You can see that in Visio, we're specifying that the attribute called R is a double. This is indicating that the return type of find area is a double. And remember, constructors don't have a return type, so you don't see a return type after the constructors, but you do see a return type for the find area method. So this is Visio notation. And when we declare an object, here's our declaration, class name, object name. So here was a declaration. And just as in any variable that you declare that is not of a primitive data type, and we saw examples of that already, that means that the variable itself is going to contain a reference to an object on the heap. But at this point, there's not even an object, because all we've done is we've declared the variable. We specified this variable is supposed to point to a simple circle, but we haven't actually created the simple circle. That doesn't happen until we instantiate using the new keyword, and of course you're familiar with the new keyword because you used it to instantiate arrays, right? And you also used it to instantiate objects, at least with the scanner class. And so you can see that sort of thing is the same with any class that we instantiate. So the new keyword is creating the object on the heap, and that is called instantiation. Anytime you see the word new, you know that there's an instance of something being created on the heap. And there is the name of the class. Essentially what's happening here is we are invoking a constructor. Because of the use of the parentheses, we're invoking a constructor. So the right-hand side of any assignment operator is an expression. So what did this expression do? It created an instance of the SimpleCircle class on the heap, and then it returns a value which is the reference to that instance on the heap, and we can use our assignment to assign that reference into our variable. And you've done that before. You've done it both with arrays and with scanners, and we'll see it with other things as well. Maybe even did it with strings. And here we can declare and create in a single step, just like we've done before. So let's start looking at what happens in memory as we go through this process. There's our new keyword. And so here is our statement right here in our application where we are instantiated a SimpleCircle. We're actually invoking the overloaded constructor in this case. Obviously, when we first dropped into the code, the main method is what executes. We're about to instantiate a SimpleCircle object. And there's our constructor. Again, a few things to say, which I already said. The purpose is to perform initialization operations, basically. The name has to be exactly the same as the class name, no return type. You can have a default constructor and some number of overloaded constructors if you wish. So what happens? Here we are, we're on our first statement in the main method. Main's frame is on the stack. We're about to go through this full process here. Our variable is declared. That means we're going to have this variable, which is a local variable of main. And our instantiation takes place. And when we instantiated, we created an object. That's a SimpleCircle object. And whatever the member variables of that class are, instance member variables, and I want to point that out. I'm not talking about static member variables. We haven't really talked about static variables of a class yet. But instance member variables. Then the instance is going to have its own radius in this case, and that's an instance member variable. So that's been created on the heap. And then the constructor gets invoked. See, so let's take a look and see what happened. So first, new created the object on the heap. Then the constructor was invoked. And when the constructor was invoked, its frame got placed on top of the stack. And its frame has a parameter called new radius, and we can see what was passed with the 5. So 5 was the actual parameter, or the argument. New radius was the, so a copy of this literal value, 5, was placed into here. And that's what we see right there. And notice another thing, that the frame of an instance method contains. It contains a pointer, a reference to the instance on which it was invoked. So this again is something new. Static methods don't have such a thing. But instance methods have a this pointer, which is pointing at the instance for which they were invoked. So that when radius is assigned new radius, well, how do we know where radius is? Well, radius is exactly the same thing as saying this dot radius. In fact, you might see examples of that in code. So by virtue of the fact that there's no argument called radius, There's no local variable called radius. The closest thing that it can find is the radius member variable of that class. I'll show you the code again in a minute. Then the knowledge when this assignment takes place is that it's going to go into there. So here's this notion of the this pointer. Instance method is associated with a specific instance. It's not a static method. This is not like the methods that you created for your last assignment having to do with just methods, in which all of them were static. There was no such thing as instantiating an object of your class. There was just methods being called. But an instance method has a this pointer. And it's also a keyword in the Java language, and we'll see the use of it and how it can come in handy later. So as a result of this action, that took place. And then that's it. The constructor's done. When the constructor's done, this expression has now been fully evaluated. So therefore, the assignment can take place. So the evaluation of this expression was twofold. It created the instance, and now it's going to return a reference, which is this arrow right here. And then ultimately, my circle is going to be pointing at that instance. And so that was our creation of a SimpleCircle object. Again, to remind us of the code that we see in this class declaration, double radius. You'll notice it doesn't say static double radius. So double radius means that every single instance of SimpleCircle is going to have its own radius. Later we'll talk about static, but now we won't. And then's our constructors. And we haven't yet talked about the invoking of the find area method. We'll get to that. So now that we have an object created, how can we access and manipulate that object? And the way that we do that to access the members of an object, which is an instance of a class, is via what's often called the dot operator or the member access operator. And you've seen that many, many times and used it many, many times. And when it is an instance member, i.e. not a static member, the way that you do that is through a reference, which is a variable. So the variable name, dot, and then the member name of the object. And if it so happens that you have a member variable that is publicly accessible, you can access that. Or if you have a method that is publicly accessible, you can call it via, again, the dot operator on that method. And that means that that method is going to be invoked for that particular circle in this case. So let's take a look and see a little bit more detail about this. So here's our member variable declaration in SimpleCircle. And you'll notice that the scope is bigger than what we've had scopes of before, because any single method of this class can access that particular variable, unlike if it was a local variable of a method. So this is often called class-wide scope. And it's also accessible because it's not private. Now, we haven't yet talked about visibility modifiers yet, but this one is not private. As a matter of fact, in the absence of a visibility modifier at all, it's assumed to be what's called protected. There's public and there's private and protected, so it's assumed to be that middle range, and we'll talk more about what those things mean later. So at any rate, because it's not private, this statement right here in main can access that particular variable. And you can see that's going to be part of what happens in a printout. And it can also be, because this is a class-wide scope, it can be accessed from multiple places within the class. And by the way, what we're really saying here when we say radius equals new radius is this dot radius. Remember this keyword. So this instance's radius. Same thing would be true down here. Radius is an instance variable. I want to re-emphasize. Every instance is going to have its own radius, not the same as a static variable, which we'll talk about later. Similarly for methods, Here's our ability to access it from outside, assuming again that the method is not private. If it was private, it could only be accessed from within the class. We'll talk more about that later as well. Whatever the variable name is, and then through the dot operator. And we see that happening here. So when we're about to call print line, before calling print line, we have to get the radius from the object, and we also have to invoke the find area method from the object, and there's our method. So if we were going to look at what takes place in memory there, we're about to call find area. We've created this simple circle. We're about to call find area on this simple circle whose reference is located in this local variable right here of main. So we're about to call it, and we can see that my circle is pointing at that object. So when we called my circle.find area, and find area, which, by the way, doesn't really have any local variables here, right? Doesn't even have any formal parameters, right? And yet there's something in the frame, which is a this pointer. And so what is the this pointer pointing at? It's pointing at the exact same thing that the reference was pointing at, through which we called find area. So there's that this pointer, again, coming into action right here. So this is pointing at the object for which the method had been invoked. And so what is find area doing? It's calculating the area and it's giving us back the results. So let's say we printed out the results. I'll run this code in a moment, but let's say we printed out the results. And now we're about to instantiate another circle. And let's see what happens this time. Now another circle is created. By the way, what happened? We declared the variable, your circle. That's why we have that there. Another circle has been created. That's the instantiation taking place. Then with the instantiation happening also, remember, is this notion that we're invoking the constructor. This time we invoke the default constructor, as you'll notice. So what does the default constructor do? It's going to put 1 into radius. Well, which radius? Now there's a couple of radiuses. Which radius? Obviously the radius that is pointed at by the this pointer of the constructor that was invoked. So once again, this use of the this pointer to be able to know which object we're talking about here. And the constructor executes, it does its thing, it's popped off the stack, the new operator returns the result, and now your circle is pointing there. So my circle is pointing at the first object, and your circle is pointing at the second object. So we have two variables, local variables in main, each of which is a reference to a SimpleCircle object, and both of those objects are located in the heap. And one has a radius with 5, and the other has a radius with 1. So here's an example of being able to access the radius variable and put 100 in it. So therefore we have 100 being put into there because it's your circle.radius that gets the 100. So it's this reference's radius that gets the 100. And then the find area on the other one. And so find area is called again, same exact method, but now was invoked with respect to your circle so that this pointer is pointing at the same thing that your circle was pointing at. And then that was the basically what was taking place in memory. So let's take a look and see how that looks in Netbeans. So here it is. I'll just try running it first. Okay, so that's the output. Let's sprinkle some breakpoints in here and see what's going to happen. So I'm going to put a breakpoint maybe right here when I'm about to instantiate, and another one right here after the instantiation and before the print line call, and I'll put a breakpoint in my constructor. I'll put a couple of breakpoints. Right at the first statement and at the end of my default constructor, similarly for my overloaded constructor, and similarly for my find area method. Let's see what's going to happen when I do that. I'll also put some other breakpoints here as well. I'm going to sprinkle breakpoints all over the place. Right before I instantiate the second circle, right before calling the print on the second circle, right before I make a change, and then right before calling the print on the second one. And you'll notice we're going to be calling methods, find area, we're going to be invoking constructors and all the rest. So let's debug this and see what happens. So I'm at the debugger. I have my call stack here. Right now we're in main. The stack is one level deep. In terms of the variables, all we got is args. We haven't yet created the MyCircle variable. Now what's happened is that we are in the constructor, the overloaded constructor. And it shows up with an init tag here in debugger, the call stack. So we're 2 levels deep in the call stack. Here's new radius, which is the parameter that was passed. And there's our this pointer. And if I expand on the this pointer, what do I got? I got my radius, and my radius was initialized to a 0. So we have the this pointer, we have new radius. Watch what happens now. The radius is changed to 5. Now, as far as main is concerned, it doesn't have anything yet because we haven't done the assignment yet. In main, what's happening in main is that it's basically waiting on this right here to take place. So let's let it happen. The constructor finishes what it's done, and now we're in main, and now we can see that MyCircle is pointing at that exact same place and is pointing at that particular instance right there with the 5. So we can now, let's take a look what happens when we're about to do the print. Well, in order to do the print, we have to resolve the argument that goes to the print method, which means we have to invoke find area on MyCircle. And so if we do that, now we're in find area, and find area is this pointer. This #114 is exactly the same thing as you see in main here. And so it's going to wind up returning the value and printing the results. So find area is going to execute. It's going to return a number. That number is going to be given back to the print, and the print is going to put that output. Here it is. The area of the circle of radius 5 is 78.53, whatever. Now we're going to create a new one. And now we have the default constructor. And the default constructor is going to, we have a whole other this pointer, pointing at a whole other location. And as a result of all this, back to main, about to do the print, and now we can see that there's one object that has that, and another object that has that. And once we're going to, again, find area is going to be invoked again now. This time when find area was invoked, it was invoked on the second one. This #129, the one that had a 1 in its radius, as you can see up here. And now it's going to be popped off the stack, and we're back to here. The next print has come out. And then we're going to assign 100 into the radius. And now, by virtue of that, and we're about to call find area again. And now, if we look at what does the radius have of your circle, it has the 100 in it. And the radius pointed at by find area also has 100 in it. So you can kind of see what's happening in memory using the debugger. So this all gets at this principle of information hiding, this notion that we provide an interface to the user via public members and hide the details via private members. There's also something in between called protected. And information hiding, I kind of split it out as a whole separate principle of object orientation. Some folks like to include that within the general realm of encapsulation. It's something to consider that this is related to the notion of abstraction. And we talked about method abstraction before, and we're actually going to bring up the term class abstraction shortly, and information hiding kind of goes hand in hand with that. So you can think of this information hiding as actually implementing the abstraction. In other words, making it unavailable to the outside world, making unavailable the things that you want to keep private. And we can actually illustrate that just by, if I go to the documentation, the Java API. And in my code examples in the module, we see a link to the Java API. Let's take a look at it. Just want to kind of illustrate to you that there are some things that are public and some things that are held within. So here's the classes again. Let me expand out on this. So here we have in the left, we have the frame with all the classes. We could focus in on a particular package. I want to look at the string class, but let's just kind of just scroll down. Look at all of these classes. Lots and lots and lots of classes in the Java API. Stuff having, a lot of things having to do with files. Okay, you were doing stuff with files before. A lot of stuff having to do with, let me scroll here, I'm in the S's, having to do with streams. Remember streams. And then finally we'll get to strings. A lot of things having to do with strings, but let's look at string. And here's string, and it's a public class. You can see the word public there. And it has all of these methods. And all of these member variables. And notice that they're all public. And the only thing we know about them is this is how we use them. And we'll know if they're static or if they're not static. In a sense, that's getting again at this notion of abstraction. And that's what is being implemented. This notion of abstraction is what is being implemented when we use visibility modifiers for the purpose of information hiding. So we'll be using modifiers in order to implement information hiding. And the modifiers are public and private and protected. And you can see what these will do. Public means anybody can use them. So if I have a public member variable, or if I have a public method, then anybody who is using that class can have access to that member variable or that method. Private means only within the class. That means that nobody outside the class, no code outside the class can access that member. And then there's something in between, which is protected. In this case, some code outside the class can access the method. For example, code in subclasses of the class, and we'll talk about that later when we get into inheritance, or other classes in the same package. And protected is the default. So when we looked at the previous example, where there was no modifier, the SimpleCircle example for the class, where there was no modifier, that meant everything without the modifier was protected. So here we see the code of that previous example. Here was the class SimpleCircle. The class itself wasn't public, it wasn't private, which meant it was protected, which meant that the class itself could be accessed from anything that is in the same package as that class. And of course, this class right here, TestCircle, was in the same package. In fact, it was in the very same file. And so it could access it. But something outside that package could not access it. And likewise, all of the members, the member variable, the two constructors, this other method right here, all were protected because there was nothing specifying public or private in these. So those also can be accessed from anywhere within that same package. Now we'll be looking at this example here, which has a class called TestCircle. This is your Oftentimes we call this the driver class or the application class. It's the one that has the main method. And here's this other class called Circle. And this other class is a public class, so it can be used by anybody. But it has a private member variable, but it has public methods. And we'll see what all that means as we progress through this. So you'll notice in the package, this objects package that I provided for you, which is similar, as I said, to stuff that's in Chapter 9. We have this class called Circle. It's a whole different file from TestCircle. Here's TestCircle. TestCircle is a whole different Java file. That's more the norm than what we saw before. What we saw before, where we had two classes in one Java file, you can do that, but you'll probably see more, and I think it makes it more flexible to have the instantiated class, the class that's intended to be an object, in its own file, because that way I can use this class in a whole bunch of other places, in a whole bunch of other files if I want to. So let's talk about when we would want to have something public versus private. As you probably kind of are surmising from this, this kind of gets at something very similar to scope. Who can access that? And so in a way, by making things private, we're narrowing the scope of them. And so the question is, what do you want to make public and what do you want to make private? Well, very often the case, what you want to make private are the data members, the member variables, because we want to do something that's very similar to what in the database class, if you remember the database class, and we talked about relational databases, and we talked about trying to enforce data integrity. And one of the ways to enforce data integrity was through something called domain constraints. And that was the idea that for a particular field in a particular table, we're only going to allow it to have certain values. For example, like a grade point average for a student. Well, that's a numeric value. I mean, we can set a data type to that and specify that it's only numbers, but it's not all numbers. It has to be a number between 0.0 and 4.0. So that's something that we would want to, in some way, provide that kind of a domain constraint, and the implementation of that in database was through the check clause in SQL. Well, similarly, we may want to restrict access to a data member in order to ensure that data that gets in is valid. And so the way that that's often done is we make the member variables themselves private. So the user of a class can't directly just assign a value into it. But then we would provide controlled access via what are called Accessor and Mutator methods. So an Accessor method typically begins with the word get, and it's just going to return the value that's in that member variable. And a Mutator method typically begins with the word set, and it's going to take an argument, which is the intended value, and ensure that it's legitimate and only put legitimate values into the member variable. And so in a sense, they're doing input verification in the same way that we did domain constraints in database. So they're called the getters and the setters, and these will be public. Let's take a look at the code for this. So here is our circle class. This is our circle class right here, and it's being used in TestCircle. And if I try to, in TestCircle, in fact, I'll do that coding in a little bit. If I try to just say that my circle.radius equals some value, I'm going to get a syntax error. I'll show you that in a little bit. The only way that we can do things is by doing gets and sets. And you can see here we are doing the get radius, which is just calling a method, and doing the set radius here when we're trying to set a value. And so let's see how that circle class looks like. So notice it's private. So that means nothing outside that class can access it. Anything inside the class can access it. You can see within the class we're accessing that member variable. And remember, within the class, if we say radius equals 1.0 or radius equals new radius, what does that mean? That means that this dot radius is equal to new radius, because this pointer is pointing at the instance, the object itself, as we talked about earlier. And then we have our public constructors, and we got our public accessor and mutator. So notice that the accessor has a return type that is exactly the same as the data type of the member variable. And notice that the set radius typically does not return a value, so it'll have a void as its return type. But it takes a parameter that's the same data type as the member variable, and that parameter is the intended value that we want to put into it. And here we have some checking going on here, ensuring that the new radius is legitimate. And what we're saying is that this radius has to be a positive number. It has to be a number at least 0. Is what this is saying. This is, remember, if you'll remember, this is kind of a shorthand if statement. This is our test, our condition, and the if part, if it passed the test, then that's what we're going to put into radius. Otherwise, the 0 is what we're going to put into radius. So this is a shorthand way of saying if new radius greater than or equal to 0, then radius equals new radius, else radius is 0, is basically what that notation was doing. So it's making sure that at least the number that's putting in is 0. If the user enters a negative number, it's just going to make it a 0. And that way it's kind of doing this input validation, as we talked about. And here's our uses of them. And let me just play with the code a little bit. First of all, if I just run it, let me go ahead and run it. So the area of a circle with radius 5 is that. The area of a circle with radius 5.5 is that. So you can see we use the overloaded constructor to set it to 5. And then we called the set radius method after that and basically multiplied that value times 1.1, and that's why we have a 5.5. What happens if I tried to do this? Set radius to times negative 1.1. In that case, what's going to happen is it would be a 0, right? It will be a negative number. And so it's making it into a 0. So we can see that that was happening. And so we can see that this code within the setter was ensuring that it's going to be a positive number. Let me do another thing here. I'm going to try to do this. I'm going to try to say my circle dot radius equal 1. And notice that I got an error. And if I hover, private access, so syntactically, you just can't do that because it's private. Another thing I'll show you is that indeed radius is the same as this dot radius. I'll actually type this dot radius and we'll have exactly the same effect. So let me run it. We went back to the original where we've got it times 1.1 here. So let me go ahead and run it. Actually, if I try to run the circle class, let me try and run that. I try to run that, and it says that doesn't have a main method. You can't run that class. But I can run TestCircle, which uses circle, and you can see it had the exact same effect. So when you're referring to a member variable from within a method of that class, you can put the word this in front of it, or you can not put the word this in front of it. It's going to come out to the same thing. So finally for this video, let's take a look at how this would be notated in UML. And basically these are the symbols that are typically used: plus for public, minus for private, and asterisks for protected. Sometimes you'll see pound sign for protected. And here's a Visio drawing showing that. So the member variable is private, and all of the methods in this class are public. So that's it for the Objects1 notes. And the next thing that we will start to look at is static versus non-static or instance members of a class.